very good morning to all my dear students. Children, as you know that tomorrow you have a test on science, and I'm here again to recall the key concepts from the lesson force and pressure. As you know that force and pressure is quite an easy lesson and easy to understand. So let's quickly recall and summarize all the key concepts or the key points, main points from the lesson force and pressure. Children, I'd like to tell you one very important thing. You have to learn for the sake of subject, for the sake of knowledge, and not just for the sake of marks. When you learn the subject well, you automatically get good marks. So try and learn the subject more importantly, not for the sake of marks, but for the sake of your own knowledge. Okay, so let's begin some key points from this lesson. What is force? All these things, by the end of the lesson, you should have a clear idea about all these things in particular. Okay, these are the main concepts that you need to have a good grip on. So the first thing is, what is force? As if you remember, we started our lesson from with explanation of this particular concept. So there are so many activities that we do daily, usually which can be classified into a push or a pull. So force is nothing but, in simple words, it is called as the push or the pull of any object or body, right? So any action that involves push, pull or pull is nothing but said to have force involved in it, right? So if you talk about the actual definition of force, it is nothing but it is something that makes the body of mass m, it is something that makes the body of some mass to move or to accelerate. By also we can understand that if a body of mass m is moving with some acceleration, say some x meters per second square acceleration, then it exerts some force. So you can understand both the ways. We have the formula F is equal to ma, m into a, right? That is, mass is usually measured in terms of m, that is kilograms in SI units, and acceleration, it is measured in terms of meters per second square. This is kilograms and this is meters per second square. So we can, either ways we can understand this definition. A force is something which makes a body of m kgs to move with an acceleration of a meters per second square. Or we can go for the other side also, like this also we can understand. If a body of mass m kilograms is moving with an acceleration of some m meters per second square, then it exerts a force equal to 1 Newton, which is nothing but the SI, which happens to be the SI unit of force, children. Okay. So what is N? Newton is nothing but kg into meters per second square. But mass can, in CGS unit of system, CGS is nothing but centimeters, grams and seconds, that unit system, we measure mass in terms of grams and acceleration in terms of centimeters per second. And in that case, the unit of force becomes dyne. So how much is 1 dyne? 1 dyne is equal to 10 to the power of 5. 1 Newton is equal to 10 to the power of 5 dynes, children. So this is the relationship between Newton and dyne. How did this come? I already explained to you. 1 kilogram is equal to 1000 grams. That is 10 to the power of 3 grams. And 1 meter is equal to 100 centimeters. That is 10 to the power of 2. So 10 to the power of 3 and 10 to the power of 2. You both multiply each other. That is nothing but you add up the powers. You get 10 to the power of 5 dynes. That is about the formula and the units of force, children. Okay. So that is very important. And coming to the effects of force now. What a force does to a body. I told you that most of our actions usually involve activities like pulling and pushing. So when you are pulling and pushing, what is actually happening to that body? There is a displacement or nothing but a change in the position of that particular object. If I move a chair from one place to another, if I push it or pull it, what is happening to the position of the chair there? The chair is moving, its place is changed, its position is changed. We have changed its state. Previously, the chair was in state of rest. By moving, you have changed it to the state of motion, right? So not just motion, it can make a body from a state of rest to move. And not just moving, it can either accelerate, that means it can increase the speed, or it can decelerate, it can bring down the speed of the moving object, or it can even change the direction of the force. As actually I gave you an example, when a footballer or football player or a cricketer, the batsman, when he hits the upcoming ball, when the ball is coming, when he hits it, what is happening? The ball is in motion. When he hits it, he's changing the direction of the ball, and the ball goes in some other direction. So what is he doing? He is applying force by way of the bat, and that's the reason that's how he is able to change the direction of the moving object. So same is the case with the football player also. He is just dodging the ball and trying to move it to in a different direction. So that is what force does. Also, it can change the size and the shape of the object also. How? You just try squeezing a lemon. So what is actually happening there? The shape of the line is changed after you apply some force. What is happening to it? Its shape is getting changed. Once you squeeze it, you are applying pressure with your fingers on the lemon, and that's how its shape changes. It gets distorted, or what you call, the shape gets changed, squeezed, isn't it? And same like you take a sponge and you can just, if you squeeze it, or you take a paper and you just crush it, so its shape and size changes. So what are we actually doing? We are applying force there, right? Now, hope you understood what are the effects of force. Any one or all the effects can be seen, children. So all these effects can be seen in any particular activity. Coming to the types of forces, here we have basically how many types of forces, children? We have two categories, two types of forces, which are contact forces and non-contact forces. So the name itself indicates contact and non-contact. All those forces which require a physical contact between the objects, they are called as contact forces. If I want to move any object, I have to push it. I can't say abracadabra, move, or something like that. I can't do, isn't it? So I have to touch it and I have to move. So that is how I am maintaining a physical contact with my chair or with my object, and then I can apply this force, right? So all those forces. So what am I doing? Actually, I am using the energy, or what you call the force of my from my muscles. So it is nothing but called as muscular force. So these forces like muscular force, can you give some more examples for contact force? Muscular force and frictional force, all these come into the what you call contact forces. Okay, friction also we have seen in a recent chapter, friction, where it is nothing but the surface phenomenon. I told you, when two objects are in touch with each other, in contact with each other, one offers some friction or some opposing force on the relative motion of the objects. When they glide over each other, when they go past each other, then what happens? There will be some opposing force which both the objects will be experiencing. That is called as frictional force. So it is also a contact force, right? Coming to the non-contact forces, these do not require any physical contact. So example is magnet. If you take a magnet, two magnets, both same poles facing each other, with same poles facing each other, then you can see that without touching each other, they will be moving apart because they will be repelling. So that is nothing but the magnetic force that they exert on each other. So there is no need of any physical contact at all. Without a physical contact, you can actually see that the force is applied. So such forces where there is no requirement of physical contact, they are called as non-contact forces. So you can see the gravity. If I drop this pen down, so if I just drop it or leave the pen here, so it won't go up, it will certainly go down because of the gravity, pull of the gravity. So the earth exerts this gravitational force without having a physical contact with this pen. It can directly pull towards it, right? So that is again another example of non-contact forces. Coming to another force, another example is electrostatic force. So this electrostatic force is nothing but this force is exerted mainly because of the charges that are present on the surface of any object. Static electricity we say. Static, electrostatic means what? Here the charges are not flowing like in case of electric current. Instead, the charges will be on the surface of the object, and opposite charges, like how opposite poles of a magnet attract each other and similar poles repel each other. In the similar manner, opposite charges, two types of charges we all know, positive charge and negative charge. Opposite charges tend to attract each other and negative charges tend to repel each other. All these things do not require any physical contact, and that's the reason why they are again they come under the category of non-contact forces. Okay. Hope it's clear, children. Then let's go to the resultant force. What is resultant force? So I have given an activity, and I think a lot of information about resultant force I have already given in my videos. Please do go through those videos. Elaborately I have explained about the resultant force. It is nothing but, as I told you, that not just one force. There are so many forces simultaneously acting on a body at a particular time, simultaneously, not just one force. If I am pushing the a block or any chair or anything, that it's not just my force that counts. There are so many other forces that come into play. But because, for example, if I'm pushing a block of, I told you that if I'm pushing a block of a box in this direction, applying some force of some x newtons, then what happens here? The box experiences not just this force but also many forces. There is an upward force that is exerted, upward thrust we say, that is exerted by the ground, and there is a downward thrust which the block itself exerts on the ground, and there is an opposite direction friction that is exerted because the two are in contact with each other. So in order to move this block, you have to overcome all these three kinds of all the other forces. Whichever side the force is more, it will move in that direction only. So I have seen that there are some cases also we have discussed, like first case when two forces are acted in the same direction. So what happens when two forces act on the same direction? Tell me, children. When two forces act on the same in the same direction, then both of the resultant force that is experienced by the block is nothing but the sum F1 plus F2. It becomes the resultant force is nothing but the sum of both the forces that are acting. Say for example 10 newtons and 20 newtons. Together it becomes 30 newtons and the block moves in the direction of force, right? If the forces are acting in opposite direction, now F2 is like this and F1 is from this direction, then what happens, children? Based on whichever force is more, say for example F2 is more than F1, so then the resultant force that will be acting on it will be the difference. Whenever two or more forces are acting in opposite direction, the resultant force is nothing but will be equal to the difference between the forces. So you can see that if F2 is more, then F2 minus F1 will be the resultant force, If F2 is greater, naturally the block will move in the same direction, in F2's direction, right? So this is more important. From the same, if both the forces are acting along the same direction, then the resultant force is nothing but it is equal to the sum of both the forces. And if they are acting in opposite directions, then the sum is then the resultant force is equal to the difference between those two forces. And the block or the body will be moving in the direction of greater force. So that is about the main concept between, if both the forces are equal, I told you that they both will neutralize each other and the block will not move anywhere. The resultant force will be 0. So there won't be any change in the position of the block. Okay. That is about the resultant force, children. Coming to the scalar or vector quantity, we have learnt about this in our lesson Force and Pressure. Is force a scalar quantity or a vector quantity? Yes, it is a vector quantity because it has got both magnitude and direction. It has got some value. A force has some value and it also has a direction. Whenever you are describing force, you have to describe about its magnitude and also the direction of the force. So that makes force a vector quantity, children. What's a vector quantity? It should have both value, magnitude as well as direction. Force has a direction as well as magnitude. So it's a vector quantity. That is about force. Now let's talk about pressure.